Slope and rate of change. Slope should be a familiar word to us, but slope does represent the steepness of a line. It is always determined by 2 points. 2 points make a line, therefore 2 points also determine the steepness of a line. When using slope, we like to shorthand everything. So the lowercase m, is going to be the letter that we use to represent slope. And we find it by using the formula of a slope is a y minus y point over x minus x point. Now some of you may be going, it was always y2 minus y1, x2 minus x1. And that's true, and that's how you'll see it in the books. But what's most important is that you always know that you can find it from any points. And it doesn't matter what you call the points, 1, 2, A, B, or anything in between. What's important is that you always take them in the same order. So as long as I take this y first and subtract that one, I have to take this x first and subtract. It doesn't matter if I want to take this one, this down here one, and subtract upwards. It makes absolutely zero difference. What's important is that you always take the same coordinate point. Whichever y value goes first, its corresponding x must come first. That's what's important. So I don't care who you call y2, y1, or even if you call them that at all. I just want to make sure that you always take the corresponding values, subtract the other corresponding values, where y is over x. The other thing that we also like to use is rise over run. You should be kind of familiar with that as well. Rise over run. The rise are the x values. The runs are the x values. So y's over x's, the change in y's over the change of x's. Rise and run. Again, you should be kind of familiar with that. We have 4 types of slopes that we are going to be working with. The first slope is going to be a positive slope. And some examples of what that might look like: 1/3, 3/2, 2. Pictorially, it increases from left to right, goes upwards. Then we have a negative slope, -1/2, -3/2, -2. It doesn't matter where the negative is, whether it's -1/3, let's put the one with the negative with the 3, or if I put the negative just straight across from the fraction bar, it doesn't matter. A negative anywhere within my fraction means the whole thing that is negative. Whether it's on top, whether it's on bottom, whether it's straight across, doesn't matter. And a negative decreases as you read it from left to right. So those are our most common, positive and negative. But we do have 2 specials. And our specials are 0. A 0 slope is a horizontal line. The horizontal line means that its equation is special. Its equation is only going to be y equals a number. There will be no x value in a 0 equation, or a 0 slope equation. And if you were to get a fraction, it would be 0 over a number, because 0 over a number is 0. The other special is undefined, or no slope. An undefined or no slope, again, its equation will look different from all the rest. It will be x equals a number. There is no y in an undefined slope equation. If you were to look at a slope, meaning if you were to do this formula, y over y minus y over x minus x, you get a number over 0. 0 can never happen in the denominator. 0 can never happen, that's why it's undefined and no slope. So these are normal, y equals mx plus b, positive, negative. But if there's only one letter, y equals x equals, those are specials. They're 0 and they are undefined. All right, when we start looking at more than one lines or more than one equations, we also have some special relationships between them. The first relationship that is special is parallel lines. Parallel lines never intersect. They look something similar to that. They can go up and down, side to side, positively, negatively. They can have all of the slope formats. But what will be unique about it is that they will be the same slope. So when you have two equations and you're asked what is the, or are these equations parallel, all you're doing is looking at their slopes. Are the slopes the same? If the slopes are the same, they are parallel. The other relationship between two lines as special is called perpendicular. Perpendicular lines intersect at right angles, and we should know that right angles mean 90 degrees. We use this upside down T for perpendicular symbol because we're lazy. We don't like to write out the words, so we like symbols. And their slopes have two components. They are opposite, meaning positive, negative, and reciprocal, which means flip the fraction, numerator, denominator, denominator, numerator. So here's some slopes. What I'd like you to do is just take a second and tell me, or see if you can fill in the rest of this chart. Give me the parallel to 1/3. Give me the perpendicular to 1/3. Negative 2/3 parallel, negative 2/3 perpendicular, and then 4 parallel, 4 perpendicular, and 0 parallel, 0 perpendicular. So I'm going to give you not too long. I want you to fill it in your notes on your own for a second here, and then I'm going to complete the process for you. All right, it really should not have taken but probably 2 seconds to fill in what the parallel slopes are. By definition, the parallel slope means that they are exactly the same. So a slope that is parallel to 1/3 is 1/3. 2/3, negative 2/3 is negative 2/3. Parallel to 4 is 4. And parallel to 0 is 0. Because parallel means exactly the same. Perpendicular means opposite, so positive becomes negative, and reciprocate, 3/1. Now we want to clean that up, so we would just say negative 3. So opposite, negative makes positive, and reciprocate means to flip, 3/2. 4 is negative. And right now, 4 is over 1. We don't write it that way because we always simplify. But I do need to understand that when I flip it, I get 1/4. 0. Well, 0 is 0 over 1. That's what it means to have it in fraction form or in rational form. So if I'm going to flip this, I get 1 over 0. That can't happen. So a 0 slope that is perpendicular is undefined. And vice versa. If I have an undefined slope, its perpendicular is going to be 0. And when we go back to those specials, a 0, remember, is horizontal. So therefore, if I'm going to be perpendicular to a horizontal, I would have to be vertical. And if I'm vertical, I'm undefined. And again, vice versa. If I'm vertical and I'm perpendicular, that means I'm horizontal. Therefore, undefined gives me 0. So make sure you understand those specials, how they work together, parallel, perpendicular, y equals, x equals, because you're going to see them quite frequently, and it is a huge expectation that you can draw them, graph them, find them, understand them, explain them quite frequently and with ease. So make sure you can do those specials. All right, and that was it for 2.1.